So hello again. We are talking about the big data technologies and the various technologies which are used with respect to big data. Since two tutorials and there's a third tutorial in sequence. So let's talk about the big data technologies survey. And obviously we are going to talk about Hadoop, Storm, and many more. Let's see what is there in the store. So big data is an extremely large data sets that may be analyzed computationally to reveal patterns, trends, and associations. And they give an idea about the human behavior and interactions too. So it is large volume of data, both structured and unstructured. Yeah, we have talked about what is structured and unstructured. Structured is something like SQL, and unstructured can be videos, audios, maybe Twitter data, maybe Facebook data. Okay, it can be CSV data, a collection of data sets so large and complex that it becomes difficult to process using the databases whatever we have in our hand. So that is the idea of it. Now there is a stream processing. This is the term which we have to talk about because we are going to talk about the stream processing only in the later part of the slides. So processing data from social media streams and sensor devices in real time is becoming increasingly prevalent, and there are ample of open source solutions are available. So there is Apache Hadoop, Apache Storm, Apache Spark, Apache Flink, etc. And they do stream processing, and it is nothing but to query continuous data stream and detect conditions quickly within a small time of period. And it is going to receive the data very fast. It is going to give us an idea that from the analytics. So this is about the stream processing. Now we are going to talk about the Apache Hadoop. Obviously, we have talked about it in the last two tutorials also. So I'll take it. I'll just touch it and just go ahead. So Hadoop consists of two key elements, that is HDFS and MapReduce. It is used for big data computing and data processing respectively. It consists of single name node and many more data nodes. It depends on how the data nodes are connected to the name node. We have talked about it that the idea about it has to be given in the core site.xml when we create the XML files, and there can be many more blocks. And I have told you all that block is of 128 megabytes, and these blocks are stored on data node, and name node is a master node which looks after how it manages the file system metadata, and data node is nothing but the slave node, and actual data what to do by the data node is actually instructed by the name nodes. So we are going to talk about the Apache Storm over here. We will look at the figure over here. We have talked about the storm also in the last tutorial. There are bolts and the spouts, and how there is a task manager in the Hadoop. In the same manner here there is a Nimbus. So you can see that the spout is passing the information to the bolts, and one bolt is passing the another information to another bolt, and there is a stream information, the streaming data. So it is all about the free and open source distributed real-time computation system. It is talking about the real-time analytics and online machine learning. Obviously, it is consisting of the spouts and the bolts. And spout is a data source, and bolt processes the data. So from spout to the bolt, the data is transferred. And obviously, it is talking about the directed acyclic graph. So you can see here there is no cycle, and it is directed from one node to another. Okay, so this is the whole topology. It talks about the Apache Storm. Now we are going to talk about the Apache Spark. So this Spark and the Flink, we are going to talk about them over here in this tutorial. So Spark has emerged as true successor of Hadoop in batch processing, and the first framework to fully support the batch and the streaming. It is also known as the Lambda architecture. Whenever it is talking about the batch processing as well as streaming, it talks about the Lambda architecture. And Apache Spark is based on the concept of resilient distributed datasets, that is RDD, and essentially having distributed immutable tables of data which are split up and sent to workers. So there is also the server and the worker, or the master and the worker, or master and the executors, such type of topology or methodology we can see. It is very similar to the MapReduce concept of Hadoop, which controls process and delegates the processing to the multiple nodes. There, the name node tries to control the process and delegate the processing to the data node. Here, it is talking about one the particular it is from the executor to the workers it is passed, so to make a complete final result, and it combines the result accordingly. And here in RDD being immutable, so no worker node can modify it, only process it and output some results to the executor. So here you can see that this is the Spark context. In terms of the Spark we are talking cluster manager, worker, and executor. So cluster manager gives an information, and from the executor to the worker always gives the information to the executor. That way it happens. Now we are going to talk about the Apache Flink. It supports batch and streaming analytics in one system. Again, it is also Lambda architecture. Flink is an open source system for fast and versatile data analytics in the cluster. It has been used by Uber and Alibaba. Uses the concept of streams and transformation, which makes up a flow data through the system, and it also uses map, filter, reduce, etc. type of functions for long running, and similar to Bolt in the Storm. So obviously here we can see the diagram in such a way that there are logs or IoT information or clicks, and maybe the various IoT tools are connected, and then there is a real time data which has been got from the transaction or the logs or the IoT systems or the databases which have been executed over here in between event driven applications or streaming applications or stream and batch applications in terms of HDFS yarn. And then the application is this is the end user application is getting executed, or the it is stored in the database back. Even we can see one more diagram about the Apache Flink. It is talking about the event logs or the historical data, but the data is real time. Here we have talked about the real time and the static data in terms of Hadoop and actually Storm. Okay, and we can see the ETL. We talked about the ETL in the last tutorial in data warehousing. It is playing an important role even here, and then it is there in the master, and master sends the information to all the workers. So this is all about the Apache Flink. Now we are going to talk about the similarities and differences. So I have started taking from Hadoop, Spark, Flink, and Storm. So why I have taken like this? Because Flink looks like a true successor to Storm, like Spark succeeded in Hadoop. So I took it as Hadoop and then Spark, Flink, rather Storm and then Flink. So there is an architecture master slaves. In case of Storm, it is peer. We talked about this bolt and the spout. So there is an information which is passed from the spout to the bolt. Okay, so we can see that over here. Then it here batch processing is done, batch or real time processing, batch processing as well as stream processing. So we talk about the Lambda architecture over here and record at a time we can see over here. Here it is warm. It supports exactly once processing mode. It allows exactly once processing mode and does the checkpointing also, recovers the task from a certain checkpoint, supports at least or at most once or exactly once. It is faster than traditional system. Obviously, we have talked about it. 100 times faster. Spark is 100 times faster than Hadoop. Flink is low latency with high throughput. Low latency with high throughput again with respect to Storm. But here, in case of Hadoop complex and lengthy, Spark is quite easier than Hadoop. Flink is configured according to the requirements. And in case of data storage, Hadoop stores the data on the disk. The Spark stores in memory. There is an automatic memory manager in Flink. And Storm talks about the data in motion. Even it talks about the past data also that we have seen in the last tutorial again. So if suppose you have missed my last tutorial, you'll have to watch it once. Here, Hadoop is low cost and Spark is high cost. Obviously, I didn't come to know about Flink and Storm, so I felt that not to write down over here. You can suggest me. In Hadoop, there is a MapReduce. In case of Spark, there is access with Apache Hadoop. In case of Flink, there is map, filter, and reduce. And in case of Storm, there is a bolt. So finally, I would like to conclude Flink looks like a true successor to Storm, like Spark succeeded Hadoop in batch. Finally, which one is better can be found out based on the requirements of various use cases, as each system has specific advantages and challenges. Thank you very much for watching. Do give me your suggestion.